Hey YouTube, it's another repair video. This is a, believe it or not, this is a Sinclair QL motherboard. I've got 3 of them as a job lot from eBay, really cheap. And they turned up with no power supply, so I've been messing around here and got somewhere. But the power supplies on these are not easy to come by. So what I've had to do is get an ATX power supply. And then I've put 12 volts into here. I'll show you this properly in a minute. 5 volts in where the output of the 5 volt regulator was. And minus 12 volts in here. I'm taking these chips off, these are regulators. So, it won't power the microdrives up, but at least it works. Okay, so we've got this jerry-rigged situation here. I'm going to power this off an ATX. It looks like a complete dog's dinner. That's because it is. Yellow is minus 12 volts. Yellow is plus 12 volts. Red is 5 volts. Black is ground. And then brown is 9 volts. And I'll explain that in a minute. So how this used to work, an original, because you can't get these power supplies, that was 9 volts DC, that was ground, and that was 15 volts AC. And how it used to work was it would take the 15 volts AC, I think, and it would split it. It would get plus 12 volts from the positive half of the sine wave, minus 12 volts from the negative half of the sine wave, and it would use that to power, I think, the video circuitry. But we don't have that anymore. So what I've done is, because the ATX can give you 12 and minus 12 volts, I've just injected them directly into the output pins of what were the regulators. So IC37 was giving you plus 12 volts, so I've just taken that off and I've injected the plus 12 volts straight into what would have been the output of that regulator. And the same on IC36. IC36 was down here. That was your minus 12 volts there where the white wire is. I've injected the minus 12 volts from the ATX directly into what was the output of that regulator. So now you should have plus and minus 12 volts. So plus 12 volts yellow, minus 12 volts white. There used to be a 7805 regulator sitting on here, and that was powering I think the main, I don't actually know what it's powering, so I'm not going to lie. Anyway, I've taken it off. That was the 5 volt output, that was ground, and that was the input. So I think it was taking 9 volts DC and turning it into 5 volts. So again, taking that off, and I've just injected 5 volts straight into what was the output, picked up the ground. So I've got a ground coming off under here because it was easy to tag off under the board, just under there. And I'll probably sort that out in a minute once I know it works. And then that ground feeds obviously the ground of the board, but that also comes up to here, which is used to pick up the ground from my little regulator here, which takes the 12 volts and the ground steps it down to 9 volts, and the 9 volts then is tagged onto a pin here, which I found, which traces back to this pin with no resistance. So I know that that's where the 9 volts should have been. So again, I'm just injecting the 9 volts straight into there. So we should have everything working, microdrives, everything. So let's see if it works. So there we are, wrap the regulator up in a bit of heat shrink just to stop it arcing out and anything. No bang, no smoke. So far it's a goodie, so I'll put it back together. Okay, just a quick one, microdrives back in, 3 screws. The bevel headed ones, not the flat ones. The flat ones hold the motors together, so just 1, 2, 1 underneath on each one. 1, 2, 1 underneath. And the thing with those is, be very, very careful of these connectors. They are very cheap and very bendy. So that's that. So there we go. Bit of an oddity really, no tapes for it or anything, so microdrives for it. And yeah, like I say, I got a job lot of them. I didn't expect to win them. Not really my cup of tea. But as it's going, it's going. Obviously the keyboard don't work, the membranes rubbish, and for some reason the lights don't work, but there you go, you can get it going off an ATX power supply. See you later, bye.